Hello again. Okay, more revision material, exam questions, complex numbers. Not going to read out the entire question because it's quite lengthy and it is for 9 marks, I believe. Yeah, 9 marks. So we've got to do a bit of work, and I'm going to try to save. Well, I'm going to watch the time. So let's get going. Let's do the math. Okay, the complex numbers are this on an argand diagram for the complex plane with z is equal to x plus iy. Find why z1, z2 and z3 cannot all be roots of a quartic polynomial equation with real coefficients. Well, a quartic polynomial will have degree 4. Now, we have z1 is equal to minus 2. That's 1 because the complex conjugate will not apply there. That's one root. But minus is equal to z2 is equal to minus 1 plus 2i. That would have a complex conjugate, so that will have 2 roots. And also z3 1 plus i, that will have a complex conjugate as well. So therefore we've got a quintic. We got 5 roots. So for 2 marks, explain why z1, z2 and z3 cannot all be roots of a quartic polynomial equation with real coefficients. Well, we've got a quintic. So how am I going to write that for the examiner? Well, I've got to do a bit of writing. I will say minus 1 plus 2i and 1 plus i and 1 plus i would both have conjugate roots. Have conjugate roots. Conjugate roots. Roots. And therefore, you would have 5 roots. Therefore, 5 roots. You have 5 roots, which makes a quintic. And that's it for 2 marks. Now, part B, and of course for part A, that's not a quartic, is it? So for part B now, you've got to show that the argument z2 minus z1 over z3 minus z1 is equal to pi over 4. Well, if I do that, so z2 minus z1 straight away, so I've got minus 1 plus 2i minus z1, which is minus 2, all over z3 minus z1. Z3 minus z1, which is 1 plus I, which is 1 plus I, minus z. Minus z. And that will give you, that's equal to, of course, 1 plus 2i. 1 plus 2i, yes? Yeah, because we got minus 1 plus 2i plus 2. So, yeah, that will give you 1 plus 2i, that's correct. Over, and this will give you 3 plus I. Yeah, this will give you 3 plus I. Oh, sorry, minus 2. Not what am I talking about here? Be careful. Sorry about this. Not z. This is minus 2. I thought something was odd because okay, minus 2. Yeah, so this will give you 3 plus I. That's better. 3 plus I. Now, now we have to rationalize that denominator. So that will give us, so if I move it down here, so I got 1 plus 2i over 3 plus I, and I've got to multiply that by 3 minus I over 3 minus I. Don't forget to rationalize, and that will give us 3 plus 5i plus 2 over and we got 3 times 3 and I time difference of 2 squares, and minus I squared, that's 1, so that'll give us 9 plus 1, which is 10. So 9 plus 1, which is 10, and that gives us 5 plus 5i, 5 plus 5i over 10. Now, the argument, therefore, our argument is equal to the inverse tan, tan to the minus 1 of, that will give us 5 over 10 divided by 5 over 10. Well, that's nice, that's 1, isn't it? So, and that gives us, of course, 90 degrees, which is 90 degrees, which is pi over 4. So that gives us the inverse tan of 1, and which is equal to pi over 4. So that's part B done. So this is part B. I better put that here. And this was part A. And this is part B continued. Part B. Oops, better. Part. Okay, it's not right in there. Let's get rid of that. Okay, part B. Part B continued. I just put continued, and let's go on to part C now. Now, part C. Let's remind ourselves of part C. Hence show that arctan 2 minus arctan a third is equal to pi over 4. So we've got some results already. So part C. Now for part C, I'm going to put a please note. We need to be aware that when dividing two complex numbers, when we divide two complex numbers, what happens? Complex numbers such as what was given to us. Oops, there's an R missing here. So we had arg, and just to write it out, z2 minus, is it z2 minus z1? Yep, z2 minus z1 over z3 minus z1. Yep. When we divide two complex numbers, we're actually subtracting them. So it's arg of z2 minus z1 and subtract arg z3 minus z1. So this is what we need to be aware of, and then we can say therefore we have our answer for this from before, which was pi over 4, is equal to, and now we substitute the value, well, the values, we got our answers here. This is our answer. Here we're going to substitute those values in now, and so that will give us 1 plus 2i, minus the argument of 3 plus I, which was on our denominator. And that will give us pi over 4. Oops, better go back, that's not very nice. Pi over 4, let's extend the page and let's write properly, or try to at least. Pi over 4 is equal to, and then we have tan to the minus 1, that's our argument, tan to the minus 1 of, now, this gives us 2 over 1, and minus tan to the minus 1, or the inverse tan of 1/3. And that gives us pi over 4, which is equal to arctan 2 minus arctan 1/3. And that's it. That's part C done. We've shown that. Now let's go back to our drawing here for our arg diagram, Now we have this point, I believe, to be this is our point 1 plus I, isn't it? Z3. Z3 is our point 1 plus I. So this is 1 plus I, and that's Z3, and Z1 is the point minus 2. Now, Z2 is going to be minus 1 plus 2I. So these are our points on our diagram, argand diagram. Now, if we find point D, part D, it says shade on diagram 1 the set of points of the complex number. Shade on diagram 1 the set of points of the complex plane that satisfy the inequality. Now, it's sensible here to just make sure, if I put D here, that we rewrite everything in terms of Z. So we got Z minus 2, and that's the modulus, is less than or equal to the modulus of Z, which is the modulus of Z minus 1 plus I, isn't it? 1 plus I, because we're just going to rewrite that minus 2 and 1 plus I. That's correct. And what does this mean? This tells us that the distance, so we've got to translate this information, the distance from some point, from a point Z, or some point, I'll stick to what I said at first, some point Z, because we write it in terms of Z, that's how the examiner likes you to put it. The distance from some point Z to minus 2 to negative 2 is less than or equal to the distance from Z to 1 plus I, Now, that's what that means. So now, going back to our argand diagram, if we got a shade on the diagram, the set of points of the complex plane that satisfy the inequality, well, if I find the midpoint between Z1 and Z3, why the midpoint? Because this is minus 1 away, so that will be minus 1 plus 2 squared, the modulus of minus 1 plus 2 squared, which is the root of 5. That will give me the root of 5. And also on the other side, what does this give me? That will also give me, that's going to be 2 squared plus 1. That's also going to give me the root of 5. So if I find the midpoint, which is somewhere here, and that will give me the midpoint, let's work down the midpoint, and it's easy to find the midpoint because we're just halving the distance there, and that will give me minus a half plus a half I. Midpoint is equal to minus a half plus a half I on the imaginary side. So minus a half, that's correct, plus a half I. And then if I use a different color and perhaps a straight line, a different color, hopefully I got it in red. Is it red? Oops, careful. Conscious of time, I need to go through these points. Z2, yeah, here we go. Oops. Z2, oh, I got it here. There you go. It's a bit thick. Could make it thinner. Let's make it thinner. Let's go delete that. Make the line thinner. Oh, it's too thick. Way too thick. Okay, let's go again. And let's go through. That's much better. That's much better. And can I go through? Yeah, okay, that's a midpoint. And something like that. Yeah. And okay, that's all right. And now again I can shade. Oh no, I want to shade. So it's going to not be on this side. If I need to shade, I have to shade everything on this side. So, and I think that's all I need to do for that question. Yep, I think that's about right. For the final whatever amount of marks, but that's all 9 marks for you. But taken a long time, 16 minutes. Okay, for 9 marks, oh, it's too long.